हॅलो एव्हरीवन. हा लॉकडाऊनचा पिरियड आहे. हा पिरियड का आहे, याची कारणं कोणकोणती आहेत, या सर्व विषयामध्ये खोलामध्ये न जाता या उद्भवलेल्या परिस्थितीला सकारात्मक दृष्टीने तोंड देण्यासाठी आम्ही सर्व शिक्षक तयार आहोत आणि तुम्ही विद्यार्थ्यांनीही तयार राहायचं आहे. या विषयामध्ये डिटेलमध्ये न जाता आपला फिजिक्स विषय हा जो आहे त्या विषयाचा अभ्यासक्रम तुमच्यापर्यंत पोहोचवण्यासाठी आम्ही काही व्हिडिओज व नोट्स टेलिग्राम या चॅनेलवरती तुमच्याबरोबर शेअर केलेले आहेत. या नोट्स व्हिडिओचा अभ्यास करत असतानाच त्याबरोबरच तुम्ही फिजिक्सचं जे टेक्स्टबुक आहे ते डाउनलोड केलेलं असेलच. त्याचाही नियमितपणे तुम्ही अभ्यास करणं गरजेचं आहे. कारण बोर्ड एक्झाममध्ये जे काही प्रश्न विचारले जातात ते प्रश्न टेक्स्टबुकच्या बाहेरचे विचारले जात नाहीत. त्याचप्रमाणे हे जे काही व्हिडिओज आहेत ते तुम्हाला दिल्यानंतर त्याच्या शेवटी तुम्हाला काही असाइनमेंट दिल्या जाणार आहेत. त्यामुळं तुम्ही हे व्हिडिओज किंवा नोट्स काळजीपूर्वक अभ्यासायच्या आहेत. सो आपला फिजिक्स विषयामधला 7th नंबरचा जो टॉपिक आहे वेव्ह ऑप्टिक्स, त्याची आपण सुरुवात आता करणार आहोत.
Students, now we start chapter number 7, Wave Optics, with the help of PPT. Most of the terms in this chapter are already studied in the 11th standard. Hence, this chapter is very easy for you and we can get maximum marks for this chapter. In the word wave optics, we are already know that what is meant by a wave, and optics means scientific study of light and sight. ऑप्टिक्स म्हणजेच ज्यामध्ये दृष्टी आणि प्रकाश लहरींचा शास्त्रीय पद्धतीने अभ्यास केला जातो. In 11th science, we have already studied that how transverse wave and longitudinal waves are propagated through the medium. Here we study mechanical waves and electromagnetic waves. First we will see mechanical wave. Mechanical wave is a wave which require a material medium for their propagation. That means mechanical wave travel through either solid or air medium, but it does not propagate through vacuum. म्हणजेच मेकॅनिकल वेव्ह ही अशी एक वेव्ह आहे की जी पुढे सरकण्यासाठी मटेरियल मीडियमची गरज असते. ती वेव्ह म्हणजेच मेकॅनिकल वेव्ह व्हॅक्यूम मधून निर्वात पोकळीमधून पुढे सरकत नाही. अँड एक्झाम्पल ऑफ मेकॅनिकल वेव्ह इज अ साऊंड वेव्ह. वी सी दिस एक्झाम्पल इन डिटेल. इफ बेल इज केप्ट इन अ जार with air, we can hear or listen the sound of bell outside the jar because air is present nearer the bell. If air inside the jar is removed, then we cannot listen the sound of bell because there is not air medium present nearer the bell. And for the propagation of sound wave, material medium must be necessary for the propagation of a sound wave. Then we see another type of a wave, which is a electromagnetic wave. Electromagnetic wave is a wave which travel through or propagate through material medium and also through vacuum. म्हणजेच इलेक्ट्रोमॅग्नेटिक ही अशी एक वेव्ह आहे की जी वेव्ह मटेरियल मीडियम मधून आणि निर्वात पोकळी मधून सुद्धा पुढं सरकते, पुढं ट्रॅव्हल होते. Students, in this PPT we observe that propagation of electromagnetic waves, and examples of electromagnetic waves are light waves, radio waves and X-rays. That means this PPT also shows the propagation of light waves. We will see example of light wave in detail. Light wave from sun travel through vacuum as well as air medium and then reaches on the earth surface. That means These light waves travel through vacuum as well as through air medium. Therefore, light waves are the examples of electromagnetic waves. Also, we see another example of radio waves in detail. At the transmitting station, sound waves are converted into electromagnetic waves, means radio waves, and then these electromagnetic waves travel through air medium, and at the receiving point, these electromagnetic waves then converted into again sound waves, and we listen sound. Also, X-rays are the examples of electromagnetic wave. Electromagnetic waves are travel through vacuum because they are produced from the accelerated charged particles, that means vibratory charged particles, and they consist of electric field vector and magnetic field vector, which are vibrated perpendicular to each other, and again both these two fields are vibrated perpendicular to the direction of propagation of a wave. In this PPT, we clearly observe that direction of vibration of waves are perpendicular to the direction of propagation of a wave. That means these waves have transverse nature, and light waves are the examples of electromagnetic waves. Therefore, also light waves have transverse nature, and it is the example of electromagnetic wave. Therefore, definition of electromagnetic wave is a wave which is produced due to the acceleration of charged particles consisting of electric and magnetic field vectors which are mutually perpendicular to each other and are also perpendicular to the direction of propagation of a wave, which is seen in previous PPT. Students, then we see what is meant by a wave optics. Wave optics is a branch of optics in which we can study the various optical phenomenon or various characteristics of a light by assuming wave nature of a light. We know that light has dual nature. That means light has particle nature as well as wave nature. Student, we know that particle nature means source of light emit light in the form of particles, and wave nature means source of light emit light in the form of a wave. And in this topic, we see various characteristics of a wave by considering wave nature of a light. And these characteristics are as shown in this PPT. That means one is reflection of light, second is refraction of light, double refraction of light, simultaneous reflection and refraction of light, interference of light, polarization of light, and diffraction of light. We can see all these characteristics one by one in other PPTs. First characteristic of light is reflection of light ray. Reflection of light ray means bouncing back of light rays after hitting any reflecting surface. In this diagram, we clearly observe that when light ray from air medium is incident on the reflecting surface, for example on the mirror surface, then that light ray bounced back into the same medium, that means into the air medium, which is called as reflection of light. Common example of reflection of light is we can see our image in the mirror. Students, listen carefully and see in this diagram that angle of incidence I is the angle between incident ray and normal, and it is not between surface and normal. Then angle R is the angle of reflection, and it is the angle between reflected ray and normal. Students, then we see laws of reflection of light wave. There are two laws of reflection. म्हणजेच ज्यावेळेस लाईट ही रिफ्लेक्टिंग सरफेसवरून रिफ्लेक्ट केली जाते त्यावेळेस या दोन्ही नियमाचं त्या लाईट वेव्हकडून पालन केलं जातं. फर्स्ट लॉ इज दॅट द अँगल ऑफ इन्सिडन्स इज always equal to the angle of reflection. That means angle I is equal to the angle R. If the angle of incidence is 30 degree, then the angle of reflection will also be 30 degree. Remember that these angles are always measured from the normal and not from the mirror surface. Students, remember that this law is applicable whenever there is reflection of light from the surface. Then second law is that from the geometry of the figure it is clear that incident ray, normal and reflected ray are in the same plane. Therefore second law is that incident ray, normal and reflected ray all lie in the same plane. Then we see next characteristic of light wave, that is refraction of light. Students, we know that what happens when light ray is incident on the transparent medium. At that time light ray transmits through that medium and it not goes in the straight line path but it bends toward us or away from the normal in the transparent medium, and it is called as a refraction of light. Therefore definition of a refraction of light is the bending of light rays when it enters from one medium to another medium. In this diagram we clearly observe that in case of refraction, when light ray enter from rarer medium to denser medium, then that light ray bends towards the normal in the denser medium. And when light ray enter from denser medium to rarer medium, then that light ray moves away from the normal in the rarer medium. Then we see laws of refraction of light. First law is that the incident ray, refracted ray and the normal all lie in the same plane. And second law is Snell's law, which is very important for you for solving examples on this topic. Here we see meaning of each term. I means angle of incidence, R means angle of refraction. Meaning of V1 is that it is the velocity of light in first medium, and meaning of V2 is that velocity of light in second medium, and N21 is the refractive index of second medium with respect to first medium. Then we see refractive index of a medium. First we see what is meant by a refractive index. Refractive index is the measure of the bending of light ray or measure of speed of light ray when it passes from one medium into another medium. Then we calculate refractive index of a medium by using given formula. That is, refractive index of medium 2 with respect to medium 1 is equal to the sin I divided by sin R, and it is also equal to V1 divided by V2, where V1 is the velocity of light in first medium and V2 is the velocity of light in second medium. In 11th standard, we already studied that relation between velocity, frequency and wavelength. Velocity equal to frequency into wavelength. Therefore, V1 equal to lambda 1 F1 and V2 equal to lambda 2 F2. Therefore, we get the relation V1 divided by V2 equal to lambda 1 F1 divided by lambda 2 F2. But we know that when any wave passes from one medium to another medium, then frequency remains constant. That means F1 equal to F2. Therefore, above formula becomes refractive index of second medium with respect to first medium is equal to sin I divided by sin R equal to lambda 1 divided by lambda 2. That means this formula is in the terms of wavelength, and I is the angle of incidence and where R is the angle of refraction. Then another characteristic of light wave is that simultaneous reflection and refraction of light ray. In nature, there are some transparent materials which shows this property of light. That means we get reflected ray as well as refracted ray at the same time when light ray is incident on that transparent medium. Then we see next property of a light, double refraction of a light ray. In nature, there are also some transparent medium which shows this property, that is double refraction of a light ray. When light ray is incident on that transparent medium or material, then we get two refracted rays as shown in given diagram. Students, to study the remaining properties of light waves such as interference, diffraction and polarization of light, you should know the terms like unpolarized light, plane polarized light, superposition of waves. Hence, we will study these characteristics in more details in the next lecture. And assignments on this lecture will be given to you, and you have to submit these assignments in time. Thank you for watching this video.